Here he is.
Hello, Tim. Let me just do this.
You have to have a prompt
How you
to
doing?
dare you.
Yes, I do. Popular.
I'm here with Mark Tillett, who's the founder of HEYNE Tillett Steels. I was going to say that you're structural engineers, but you're a bit more than that, aren't you?
Yeah, we kind of we do lots, expanding services all the time. Engineers of everything.
You've never seen as many engineers as there are in this building. Can we go upstairs?
Yeah.
Excellent.
Yeah.
So riveted beams in a 1930s building, isn't that unusual?
No, the interwar, they still had lots of riveters.
But they didn't
have power.
They weren't hammering though, they were. So tell me about materials. Can we go and have a chat?
Yeah.
Because it seems to me that the maths, which is what I always used to think engineering was all about, is something that is relatively straightforward if you've got a mathematical brain.
Yeah.
But actually, the crucial thing is actually to understand materials. Is that?
Yeah.
No, that's right.
Yeah, it's completely about materials, and you need maths to then prove what your thinking and your feeling is. But really a fundamental understanding of how they bend, how they break, how they might come together, steel and concrete, and work compositely. And this is knowledge kind of gained practically through working with stuff with your hands.
It's empirical.
Empirical from a young age. Fixing stuff, breaking stuff, messing around with cars, doing part-time jobs.
What did your dad do for a living?
He was a builder. So I worked a lot with my dad. But it gives you an appreciation of the force required to break a material. And I think that kind of instinctive knowledge is utterly essential to be a good engineer. And it's not just understanding base materials, it's understanding how they've evolved over 200 years. We are in the business of adapting existing buildings, the last thing being to demolish or take them down. So engineers need to understand probably 200 years of the evolution of how materials have been brought together. And there's huge innovation, much more so than there is today, at great speed in the past. And so our challenge is training up engineers for these unique skills, not new build skills, but historical knowledge and the evolution of construction.
It's interesting as an engineer's office, this, because actually you can see exactly how it's built.
And we built it through COVID. We changed a lot because I actually think that the best buildings evolve and the best designs evolve, which is a problem with our industry. It doesn't allow that to happen. But all of these kind of details, none of this was actually drawn. It was kind of indicated on an architect's plan. And this is basically bashed out with a T-section bashed out to this shape. And there's another lovely one, these kind of swan necks. And it was all kind of shaped and formed on site. So this is where the roof used to stop. And we bought this with a consent for a fairly boring flat roof. Right. And we thought we need to do something more exciting here and build this huge concrete space on the top. Out of CLT and the roof structure, and there's lots in the press at the moment about the vulnerability of CLT to water ingress. But, we can be brave and we can take risks because it's kind of our money and our building.
Did you have an architect involved in this?
Yeah, Ian Chalk.
Ian Chalk.
Ian Chalk Architects. He put himself in our office when he first set up, and it's been a good collaboration because it's emotional building a building, and things go wrong, and you got to fix them. It's stressful being an engineer. Who's an engineer?
It's interesting, isn't it? So I've always thought that architecture was about people.
Yeah.
And engineering is about stuff.
The projects I really like are ones where we can make a significant contribution
to the people.
To initially, from a neural point of view, to the building, the thinking and the thought, things where you can make a real difference. So new build can be challenging, but heavy refurbishment is incredibly challenging.
And that's really the way the world's going, isn't it now? About trying not to knock things down.
Yeah, the team thing is really interesting because, you need a team, you need the global thing to work. So you need a great architect who, not a star architect, but just a very good architect who knows stuff that we don't and has talents and skills, and we learn and just really inspired by what they create. But then you need engineers, and we try and have the smallest teams possible so that our people take ownership. It's a stressful role being an engineer. Every decision you make is critical. And our people make thousands of decisions each year, and some of those can go wrong, right? And then you have to fix them. And so we're not making decisions on texture or color or how things move through space. Everything we're doing is about the criticality of how much material you need, and how they come together, how they fix together, how they work together. And if we get that wrong, then it's an issue.
Well, I've always thought that the best engineers are the people who use the least materials. Is that true?
That's right. So, but that comes a bit further down the line. First thing is totally understand the structure you've got, the asset you've got, right? Sweat it as hard as possible. So add as much load as you can, and we can always push it harder than it originally went. And then what you put back, put as little back as possible with the new structures, make those as efficient as possible. That's about bravery, really.
Yeah, it's about risk.
I want to show you something I want to show you a couple of things in our basement, actually.
So we're going down to the basement, are we?
Yeah, let's
Let's
do it.
go. We've got you down as a change maker, and a
Alright.
change maker, by definition, in my mind, is somebody who can't stop thinking about what they do.
I've always loved work. I think it's the greatest gift we have as human beings, the ability to work, to do something useful. And when you're an engineer, these are the jobs I like doing, where you can make an impact, where you can be useful, and where either on site, when we design everything, we do this thing called total engineering, where we do temporary works, we do permanent works. We're trying to bring more responsibility back onto consultants, on us, at a time when lots of stuff is being franchised out. We like taking the ownership, that design responsibility, because it's exciting. It's exciting owning that risk. We weren't going to do a basement, but then we thought we'd never get another chance. It's expensive, so let's make it work hard.
So there's no reinforcement in this thing.
No, these are actually reinforced, but what we've been able to do is take away all of the liner wall. So ordinarily you'd have a 300 thick concrete liner wall inside something that's perfectly capable of taking all that force. It's like we put facades on buildings now when the facade itself can carry the load of the building. So we wanted to try new things. So here you have no liner wall. We've got, it's about 700 mil wider in every dimension because of that. It's way cheaper, it was quicker, way less carbon. But people don't do this because there's a perceived risk of water ingress, and it's this warranty culture we've kind of got into, where you franchise design out. Too many companies are taking responsibility and they all cover themselves. So what we did here, we did have a bit of a leak, but we actually addressed it as we found it. So the weak point is always the joints in structure, saying earlier about how materials come together. So we've just done a thing there, and now we are bone dry. So this space here, this was going to become a gym, but actually no one wants to work out here at work with other people.
Not here.
No. So what we're going to do is something I've wanted to do for years, which I'm grandly calling a testing lab. So this is really not to find the next graphene, but just to give people a better understanding of how materials, glass, aluminium.
So what are you going to do? You're going to bend stuff and break stuff?
Yeah, bend it, break it, have a rig here, see it smash. That's for staff, for ourselves, for our own amusement, to test calculations and numbers against what really happens empirically. Get school kids here, get them involved. We get lots of schools come for our building, but if they can see stuff being broken, they'll be interested.
Mark, it's been great fun talking to you. Thanks
You-
very much.
Thanks for coming over.